Okay. Okay. Next is about the IP terminology. Some terminologies with related to IP, Internet Protocol. First is bit. Bit. What is a bit? A bit is one digit, or either 1 or 0, either 1 or 0. That's the definition. Second is byte. A byte is 7 or 8 bits, depending on whether parity is used. For the rest of this chapter, always assume a byte is 8 bits. Okay, so normally 1 byte is 8 bit. Sorry, 1 second. So 1 byte is 8. Third is octet. An octet made up of 8 bits is just an ordinary 8-bit binary number. In this chapter, the terms byte and octet are completely interchangeable. Okay, so octet and byte is similar. We can say it is similar. Fourth is network address. This is the designation used in routing to send packets to a remote network. For example, 10.0.0.0, 172.16.0.0, or 192.168.100.0. This is the example of the address. We will discuss further about this later. Fifth is broadcast address, used by application and host to send information to all nodes on a network. Example includes 255.255.255.255.255, which is all networks, all nodes. Okay, or 172.16.255.255, which is all subnets and hosts on the network. 172.16.0.0 and 10.255.255.255, with which broadcast to all subnet on network. Okay. Next, private addressing. So address classes are divided into class A, class B, and class C. So what is the difference? Class A, reserve address space between 10.0.0.0 through 10.255.255.255. These are class A. For class B, 172.16.000 to 172.31.255.255. These are class B address. Class A, class B, and for class C, 192.168.0.0 to 192.168.255.255. So these are class C. So class A 10, class B 172.16, class C 192.168.0.0. Private IP addresses are not routable through the internet, okay, due to security, safe IP address space, and also network address translation, NAT. IP terminology. Each device on TCP/IP, IPv4 network use a unique 4 byte or 32 bit 4 byte or 32 bit decimal IP address for communication and is composed of two distinct parts. So for the IP address, it has two parts. Okay. The first part is network address and the second is host address. Okay. This address scheme is known as dotted decimal notation, where each byte, 8 bits, in the IP address is called an octet. Okay. IP address are 4 octets long and house the address of the host machine, the network to which it belongs. Each octet or each byte or each 8 bits is separated by dot or point dot. In this IP address example, the first octet is 172. Okay, this example. Sorry, we make it circle. 172.16.10.100 or 172.16.10.100. In this IP address example, the first octet is 172. This value on the IP address class lists length between 128 and 191 and is designated as class B network. Okay, still remember just now, this is class B network. 172.16 is network portion. This is class B, and the first two octet is belong to network portion of the address of the addressing, and 10.100 this part is the host portion. So you have network portion and host portion of the address on this 172.16 network. So this is the network 172.16 and 10.100 is the host. IP ignores the host portion on the IP address and only use network portion to route packets between network. The complete 4-octet IP address is used to make final delivery decision. The complete 4-octet IP address is used to make final delivery decision to exact node on the destination network. Okay, so this is the IP address example. We have 4 octet 172.168.16.100 or 172.6.10.100. So the first octet belong to the network, and the second two octet belong to the host. Okay. Network addressing. The network address uniquely identifies each network. The network address uniquely identifies each network. Every machine on the same network shares that network address as part of its IP address. So network address. The node address is assigned to uniquely identifies each machine on a network. This number also can be referred as host address. So we have a network address and host address or node address. The designer of the internet decided to create classes of networks based on network size. For small number of networks possessing a very large number of nodes, they created the rank class A network. At the extreme is class C network, which reserved for the numerous networks with a small nodes. Okay, so this is the comparison between class A, class B, class C, and also class D and class E. So for class A, we have only one octet or 1 byte for the network, and another 3 byte or 3 octet for the host. So this class A is considered small network but have large number of hosts. Okay. Okay, for class B, there are 2 octet or 2 bytes for network and another 2 bytes for the host. So you have the first two as similar as the example we have discussed before. And for class C, we have 3 octet or 3 bytes for the network, and only one byte, 1 octet for the host. This is considered large network but with a small number of nodes. This one for class C. Numerous networks or large number of networks but having small number of nodes. So you have large number of networks, you need 3 octet for the network, and you have only 1 for the host. Okay, so you can see the difference between the number of octet, number of bytes for class A, class B, and class C. The difference between class A, class B, and class C. Okay, next. Class A addresses: network, node. So you have a small network but large number of nodes or hosts. Example IP address 49.22.102.70. 49 is the network address. Okay. The first byte or the first octet. 22.102.70 is the node address, is the host. Network 2 to the power of 8, but because reserved digit 0 refer table, thus become 2 to the power of 7 equal to 128 unique class A network address. Okay. Class A address use 3 bytes. 3 bytes. This one. 1, 2, 3. 3 bytes or 24 bits because 1 byte is each 8 bits. Okay, for node address. This is 2 to the power of 24 minus 2 reserved bits. Okay, for a total of 16,777,214 possible node address for each class A networks. So 2 to the power of 24 is around this number. So you can have a lot of hosts for this class A address. Class A valid host IDs. Example how to figure out the valid host ID in class A network address. First is 10.0.0.0. All host bit of is the network address. 10.255.255.255. All host bits on is the broadcast address. The valid hosts are the number between the network address and the broadcast address. The valid host is the number between this and this network address and broadcast address. Meaning 10.0.0.1 through 10.0.255.255.254. Notice that zeros and 255s are valid host IDs. All you need to remember when trying to find valid host address that the host bits cannot all be turned off or on the same time. Class B address. Network.network.node.node. Okay, so you have 2 bytes for the network and another 2 for node or for the host. Example IP address 172.16.30.56. 172.16 is the network address and 30.56 is node address. Network 2 to the power of 16, but because reserve digit 1 and 0 referable, thus become 2 to the power of 14, equivalent to 16,384 unique Class B network address. A Class B address use 2 bytes for node address. Okay, so 2 bytes. This is 2 bytes. This is 2 to the power of 16 minus 2 reserve bit for a total of 65,534,000 possible node address for each Class B network. So for Class B, you have possibility having 65,000 plus possible node address for each Class B network. This number is from this one, right? 2 to the power of this one. You can check with your calculator. Class B valid host IDs. Example, how to figure out the valid host ID in a Class B network address. So Class B always 172.16. Okay, 172.16 between all host bit off and all host bits on the broadcast address. So this is .255.255 is the broadcast address. So Class B valid host ID between these two numbers. The valid hosts are the number between network address, this one, and broadcast address, this one. Okay, so the number are between 172.16.0.1 through 172.16.255.254. Okay, next is the Class C address. Class C address have 3 bytes for the network and 1 byte for node. Example IP address 192.168.100.102. 192.168.100 is the network and 102 is the node address. Only 1 byte for node address. Network 2 to the power of 24 because reserve digit 1 and 0 referable, thus become 2 to the power of 21 equal to 2 million. More than 2 million to nearly 2.1 million unique Class C network address. A Class C address use 1 byte for node address, only 1 byte. This one. This is 2 to the power of 8 minus the 2 reserve bit for a total of 254 possible node address for each Class C network. So 2 to the power of 8 equal to 256, I guess, minus 2 reserve bit. So you got 254. So that is the Class C address. So Class C valid host IDs. For example, how to figure out the valid host ID in Class C network address 192.168.100.0. This is the all host bit off in the network address, and 192.168.100.255 all host bits on is the broadcast network, broadcast address. The valid hosts are the number between this number, network address, and the broadcast address. Okay. So between 192.168.100.1 through 192.168.100.254. Okay, IP terminology. Each of these 4 octets for the IP contains a decimal value of 0 to 255 or 256 number from 0 to 255 that is translated into binary format by the computer. Each bit in the 8-bit octet has an assigned value of 1 to 8, 64, 32, 16, 8, 4, 2, and 1. An octet decimal value of 0 would look like this. So it has 8 bits, okay, in binary. An octet decimal of 255 would be represented in the binary of all ones, or this one. 255 meaning 11111111. Okay, so that is the meaning. So in the binary number, this is the real value. Okay, but normally it is written in the normal 10-base number 255. Okay. Understanding network ID, host ID, and subnet mask. To understand IP address resolution, you need to understand how to decode the IP address and extract the 2 main identifier. First is the network ID, and second is a host ID. A network ID is the network bits, and host ID is the bits the system administrator control locally when assigning IP address. The network ID identifies the number of networks, okay, and the host ID identifies the number of hosts in the local area network. This is determined by the number of bits found in the network portion of the IP address and the number of bits found in the host portion of the IP address. So we have understood what is network ID and what is host ID on the address. Okay, so until then, so that's all for the network ID. So hopefully you can understand a little bit about the network ID. So in this part, we will continue in the next video. So that's all. Thank you for your attention. Until then, we meet again in the next video.